Hello. Today, you're talking about temperature in the greenhouse and how it can be used to affect the shape of a plant or the rate of its growth. Um, Temperature is in a greenhouse is sort of it's not entirely under our control, right? I mean, we've got thermostats where we can set a temperature, but Mother Nature has her own plans sometimes, right? So we know that the sun obviously shines on a greenhouse and heats it up. But there's also things like weather, like clouds, that impact how much sun is hitting the greenhouse on a cooler day, or also how much heat is reflecting back to a greenhouse. So we know that in the winter, at an overcast winter day, the greenhouse doesn't lose as much heat as it does on a clear overcast day. So there's a lot of external factors that affect temperature in the greenhouse. Uh, How do we control solar gain? That's what we call heat from the sun. Well, we have things like curtains. We know that there's different seasons. We can plan our crops according to the season for temperature. There's also the time of day that affects when a crop is going to be uh, achieving a certain temperature. Uh, there's also the temperature will affect things like I said earlier, crop growth and transpiration. So we can affect things like humidity by venting heat off or keeping it in. That will also affect transpiration and change the rate of growth. We'll talk a little bit more about this stuff as we go through. Clouds, again, they can block the sun, keeping the greenhouse cooler. They can reflect heat back in the winter. They also can cause diffuse light. This is something you can probably go outside and experiment with someday. On a sunny day, your shadow is hard, so you got a dark line around the perimeter of your body if you look at your shadow. And on a cloudy day, your shadow is not that defined. And in some cases, that's actually beneficial for a greenhouse crop because the clouds diffuse the light, so it's coming from lots of different angles. And that means that leaves lower down in the crop actually get more sunlight. So in some instances, you get better growth or more uniform growth if you have diffuse light over a clear, sunny, blue sky day. Um, we also know that diffuse light affects humidity, for example. You get a little better humidity in the greenhouse. Um, So here's just an example I pulled from a paper talking about how clouds affect temperature spread. So you can see that in the dark line, which is under cloud, there's less solar gain, but there's also less heat loss at night. Things that affect temperature in the greenhouse, this is not always obvious, but plants actually have a huge impact on the temperature in the greenhouse. On the left here, I've got a cooling station. I don't know if you've ever been to Wonderland where they got those high pressure fog things to cool you on a hot day. Um, so high pressure fog is something that people can use in the greenhouse. But if you have enough plants and they're large enough, the plants themselves have an evaporative cooling effect in the greenhouse. So if you're going to be spending some time in the greenhouse this summer with me, to be honest, I'm going to try to get us out of the greenhouse as much as possible because it's currently too hot. Because we don't have a lot of greenhouse, we don't have a lot of crops in the greenhouse in the summer, and that's when things really start to spike in temperature. It depends on the crops too. You know, if you've got a big greenhouse and only have little 4-inch plants, even if the entire greenhouse is full of them, it's not quite the same as if you have a big greenhouse full of high wire tomato plants, because the tomato plants have so much plant mass that collectively their transpiration cools the greenhouse significantly. And people who work in a veggie greenhouse really appreciate that because even in the middle of the summer, if you're walking down the rows, it's quite comfortable. Um, Sorry, my allergies are acting up today. So one thing about temperature, let me get into some of the chemistry because it's going to be important as we go through the lesson. And it's not too complicated. It's just that you should understand that temperature affects chemical, or in this case, biochemical processes. So typically, as the temperature gets warmer, the process moves along more quickly. And if the temperature is cooler, the process slows down. So things like photosynthesis, respiration, and the production of sugar and the movement of sugar is affected by temperature. Also, the movement of gases. We'd often like to think of oxygen and CO2 in terms of photosynthesis and respiration. And yes, moving in and out of the greenhouse itself is important, but what's more important is getting the gases in and out of the leaves of the plant. And temperature plays an important role in that. And if we can't get the gases in and out of the leaves efficiently, the plants become limited in CO2, for example, even if there's enough in the air, just because they can't get the gases moving in and out of the leaf effectively. Um, Temperature also controls differentiation. So we'll probably learn that at some point, not in today's class, but there are plants, for example, your common Phalaenopsis orchid. It changes or differentiates based on average daytime and average nighttime temperatures. So typically, the orchids flower when the daytime temperatures are cooler, and so in the summer, when temperatures are warm, orchids tend to be what we call vegetative. And if you put your orchid near a window in the winter, the cool air coming off the glass, not so much the photoperiod, the cool air will cause it to flower. So there's a little secret for if you want to rebloom your orchids. Right now is the time to baby them, feed them, a little bit of fertilizer, get them happy, cut any old spikes off, unless it's really beautiful, leave it. And then let the plant just grow and build up sugars. And then in the late fall, move it to a window and let it experience cool temperatures, and you'll get a spike. Um, we'll also learn later in today's class how temperature can be used to control what we call plant habit. That's a fancy term for the shape. So we can make it more compact. We can change the dimensions of the leaves and the stem using temperature. Um, well, yeah, here it is. So, for example, we can affect the size and thickness of a leaf. We can affect the diameter of a stem or how long the stem is. We can also impact the quality and the number of fruits or flowers. And of course, temperature also can cause deformities and disrupt pollination and other things that we have to be careful about. And typically, it's the extremes that we're worried about when it comes to pollination and deformity. Uh, Here's your classic red pepper. On the top is, I guess you could call it a normal red pepper, and the bottom is the same variety, but grown where nighttime temperatures are too cold, and it causes it to, I call it pumpkin peppers, but that's a physiological response to incorrect temperatures. And this typically happens in areas where you have cold draft. Uh, Pollination can be impacted by temperature for various reasons. It can impact the movement of pollinators. It can also impact the shedding of pollen. And in strawberries, a lot of times when people see deformed strawberries like this, they think, "Oh, it's fungal or something wrong." But no, it's actually just it's not properly pollinated. Remember, strawberries are on a cane, and the seeds are in the exterior. And if they don't all get pollinated, the ovaries don't all swell, the fruit will enlarge in a regular pattern. Temperature itself for photosynthesis, there is a minimum and a maximum. This graph is attempting to show, it obviously plateaus. Up to about 35 degrees Celsius is when photosynthesis, after you get past 35 degrees Celsius, sorry, photosynthesis begins to become inefficient. And below 10 degrees Celsius, typically it is not particularly active. So there is an ideal temperature. It's pretty broad, like 25 degrees Celsius from top to bottom, that photosynthesis can work in, which is not bad. And obviously there's like varietal changes in here, plants that are adapted to cold versus plants that are adapted to high temperature. There's all that variability in there, but on a whole, between 10 and 35 is where photosynthesis can happen. And greenhouses in the summer, if they're not kept cool enough, plants will actually stunt and not grow. They may take up to 2 times longer to grow than normal And it's primarily because photosynthesis just cannot happen properly. Some plant science one review, just so you understand. Remember, photosynthesis, we're taking CO2 and water and sunlight energy, and we're making sugars. And then, of course, in respiration, we're taking sugars and oxygen and CO2 and producing CO2 and driving it the other way. That CO2 shouldn't be there. I'll delete that. So the idea is photosynthesis is making sugars, or what we call building blocks, and respiration is taking those sugars or building blocks and making stuff, either growing new material or maintaining it. Keep that in mind as we go through this next series of slides, right? So remember, photosynthesis is building blocks, respiration is building things. So photosynthesis happens obviously only during the day, unless, of course, you have grow lights, something to keep in mind. So we're accumulating sugars and we're moving those sugars around. Respiration converts sugars into chemical energy that drives various processes for building structures and hormones and moving sugar, what we call translocating it. Plants obviously need both. And if you don't have enough sugar, your plant will not grow properly. So really, we don't want to get too lost in the weeds here. The idea is today we're talking about temperature and how temperature affects growth. And keep in the back of your mind that temperature affects the production of sugars and the building of plant material. So we have respiration at night when plants are burning through those sugars and they can deplete the reserves. Now, typically, temperatures are lower at night, which does help in slowing respiration. But there is a scenario where respiration ends up consuming more than what we have. So we got to be careful about that. Should temperature be the same for 24 hours? Well, some things like seeds and germinating are fine with that. But if you think about it, there's a fundamental difference between a seed germinating and a plant growing. A plant growing is relying on photosynthesis to make all the energy to drive growth, whereas seed, all the energy has been pre-made in the cotyledon. So the seedling is independent of photosynthesis, respiration, temperature differentials. So a constant temperature is just fine typically for seedlings because you're really just trying to drive the conversion of the fats and oils in the cotyledon into sugars to drive a root radical and then ultimately emergence of a shoot. Once you have true leaves showing, well, then obviously at that point, temperature differential starts to kick in. But during plant growth, typically we don't want respiration to exceed photosynthesis, or we're not going to grow much. So think of it as, I like to use the example of putting money in the bank. If our photosynthesis is only putting $20 in the bank and we're spending $20 every day, you're not going to build up any savings. So if your photosynthesis is not able to produce more sugars than the baseline to maintain plant physiological activity, it's hard for the plant to build new structures. So we want to slow respiration at night. Now keep in mind, respiration happens 24 hours a day, photosynthesis only during the day. So we can't change the rate too much during the day because we want to make sure photosynthesis is optimal, but at night we typically have a cooler temperature so that respiration can settle down and not burn through our reserves. So the change between day and night, this is where we start to play with plants and to manipulate them. Something called diff, day to night differential. When we diff plants, that means that we're changing the day and night temperatures to manipulate the crop. Typically what that means is you take the day temperature and subtract the night temperature. So on here in this scenario, we have 22. The first example is 22 degrees during the day, 12 degrees at night. That's a 10 degrees positive diff. Now, if we have 19 during the day and 19 at night, we have a 0 diff. And if we have 15 during the day and 20 at night, we have a -5 diff in temperature. So here's how we calculate it. Remember, you take your day and you subtract your night. If we have a positive diff, plants tend to be somewhat taller. If we have a negative diff, plants become compact. I would go so much as to say that basically a positive diff means the plants will grow, quote, normally, unless you have an extremely positive diff, then you can stretch them. Uh, and where a negative diff, which is something that doesn't typically happen in nature, it's unusual to be warmer at night than during the day. So that is a very unusual physiological event. And so plants will grow unusually, and they typically become abnormally compact. Um, so under positive diff, we have stem elongation. Under negative diff, we have decreased stem elongation. And under zero diff, we tend to have larger leaves and minimal flowering. So zero diff meaning no difference. Zero diff tends to not be used very often in the ornamental world, but it can be used in the vegetable world if we're trying to impact what we call vegetative generative balance in a crop. There's an important thing I don't have in any of the slides here, but I'll mention it while I'm here. Typically, when you're diffing a crop, you do not diff it more than a couple of days at a time. So you don't just set up a diff in your computer and then walk away and leave it for a couple of weeks. You will really, really affect the health of your crop. And I've got an example coming up that will show that. That's my hint for the question. Just wait, hold on to that thought. So here's a Easter lily crop. This is a crop where it responds really well to temperature. It's also a crop that's really challenging to grow on spec. That's what we call when the plant has the right number of flowers and is the right height. It can get a bit ridiculous in the ornamental world with the specifications that growers have to meet. Otherwise, crops get rejected by the buyers. So we use temperature and growth regulators to manipulate the height of the crop. This is a little experiment that Bill McDonald, who's retired now, did with some hemp with the students in the cannabis program. And on the right, we have a positive diff, which has taller plants and larger leaves. And on the left, we have hemp seedlings that are smaller with a negative diff and shorter. Looking at it again, you can see the difference is pretty clear. Tall versus compact. Now, why do you think the negative diff is a bit yellow? Remember what I said a couple of slides ago? So negative diff means that the nighttime temperatures are hotter than the day. And I said that typically you would only diff a crop for maybe 1 or 2 days at a time max. Then you would grow it on and take measurements. Now, they diff this crop for a longer period of time. And you can see that that shift in increased respiration at night consumed sugars, and the plant had to compromise and was not able to build as much chlorophyll. So it looks yellow. So you would not diff for more than 2 days. Typically, it's just 1 day, and then you wait 5 days and take a measurement, and then you do a deep diff again, and then you wait 5 days and take a measurement. This is a picture of vegetable seedlings that are being grown to be sold to a hydroponics farm. Diff is something that these growers use a lot to control stretch. If the plants get too tall, they can be challenging to ship. The growers typically get upset if they're stretched when they're shipped. So they really have to try to maintain proper height control with those. Now, these are low value crops, and it can become very expensive to maintain a high night temperature for the entire night. For, if you're doing it every 5 days, it starts to add up. So what can be done? So there's something potentially, well, there is something called the drop. So what that means is if we look at the physiological activity of plants, researchers know that Stem elongation typically happens at the morning or evening, so the beginning or the end of the day. Now, if we only disrupt that temperature at that time of the day, can we affect the size of the plant? And the answer, of course, is yes. So what do? We have a sharp drop in temperature at sunrise, typically in the morning, and we hold it for about 2 hours, and that has the same effect as a negative diff. Now, you might be trying to understand what I'm talking about here because they have the same effect, but they seem different. Remember, a negative diff means a warm night temperature, right? And a cool day temperature. Where a drop, which has the same effect as a negative diff, is going from a regular day temperature to a brief, really cold temperature. So that mimics the warm night, cold day, but only for 2 hours. And that works really well when outdoor temperatures are cool. So fall, winter, and spring, not summer. Typically, the summer, your nighttime temperatures are not cold enough to achieve a deep enough dip to affect a real crop change. Um, Maybe that depends on your climate, where you are on the planet, things like that. That obviously is an effect. But if you're in the fall, winter, or spring, obviously outdoor temperatures are cold. So in the morning, you open your vents and you dump a bunch of cold air in the greenhouse, hold that for a couple hours, and then bring it up to your day temperature. So here I stretch the picture to kind of exaggerate because this campanula is not exactly, screaming growth change from this research paper, but you can see the differences. So the zero diff and the positive diff, the plants are stretched. The negative diff is very compact, and the 2 hour drop is also pretty compact. Not quite as compact as a full-on negative diff, but pretty compact. And look at the drop. It's down to 12.7 degrees Celsius. So that's pretty extreme. So this is typically, you program your set points in the greenhouse computer, and then in the morning hours, you drop it abruptly down to a cold temperature, hold it for 2 hours, and then bring it up to your daytime temperature. Effectively, what that does is, remember, temperature impacts biochemical processes. And if plant hormones are moving around in the morning to stimulate growth, by dropping the temperature, we can slow the movement of those hormones so they're less effective in causing that rapid elongation, which the plant is trying to do every day, and then spend the rest of the day filling in the gaps and strengthening the growth that happened in the morning. Another thing that we have with crops and temperature is something called the daily average temperature. So we know that diff, as I just finished saying, diff affects the shape of a plant, right? Negative diff keeps it compact. But what if we keep the ratios the same and we just raise and lower it, right? And that's what the daily average temperature is all about. This is probably a number that growers pay more attention to because it affects the overall speed of a crop. We have a lesson coming up later in the term on scheduling, and daily average temperature is a big component in managing your crops to fit a schedule. Typically, we want them to ship at a certain time, especially in the ornamental world. And so your DAT is something you carefully control and monitor to stay on time. Now, how does that work? You take your how many hours of daylight you have and the temperature during the day, and how many hours for your night and the temperature for the night. They have to add up to 24 hours, then divide it by 24 hours, so you're left with only the average temperature. And that gives you your DAT for your 24 hours. What does it mean? Well, okay, overall higher DAT, we have more rapid node formation, so that's branching leaves. We get faster leaf growth. We mature more quickly. We flower quickly. And we typically have a modest increase in internode length, so a little stretching. With a lower DAT, obviously things are slower, so you get slower branching. We get slower maturing, slower flowering. And we have a reduced shoot to root ratio. So what that means is if you took a plant out of a pot and you washed all the soil off, there's more roots relative to the top of the plant under a lower DAT than under a higher DAT. So sometimes, for example, especially in the perennial world, when you're trying to establish a transplant, you might run a lower DAT to encourage root formation. There's other things that we can do. So it really depends on how much time you have, but that's an option. I want to finish up here with talking about microclimates because that relates to what we're going to do in our labs um, this week. Uh, with microclimates, we have things that impact the uniformity of your climate in a greenhouse. So things like movement of air, plant density or spacing between the plants, proximity to exterior walls or walkways or corridors, whether you're on a southern wall versus a northern wall. All these things impact microclimates, and we're going to walk around and take devices and measure and look at microclimates. It's not just about greenhouse. I know not all of you are greenhouse students. Microclimates play an important role in a lot of different contexts. Um, from designing gardens to understanding the cardinal direction of the house, where is north, south, uh, looking at proximity to walls and shading, density, open space. All these things impact temperature and humidity and can make a part of the garden more suitable or less suitable for certain crops. So microclimates are something that are really important to take into consideration when you're planting a garden. Not only that, but density of the plants. Just like in the greenhouse, when there's more plants together, they create a favorable environment um, for certain plants and less favorable for others. So, for example, if you're xeriscaping and you're growing a lot of cacti and succulents, well, they like it hot and dry. So high density is not going to be in your favor there. They like space. They like it away from the shade. They want to be in the sun. But if you're growing something with delicate flowers, like here we have a poppy, uh, they're a sensitive plant. They prefer a little more density. They like a little more shade. Not completely shade because it is flowering. Very few plants flower well if they're in a lot of shade, mainly because flowers require a lot of sugar, and if you're in the shade a lot, you can't make a lot of sugar, so it's hard to flower. So that's why not a lot of plants flower in the shade. But anyways, microclimates. I think that's the end of this lesson. Try to keep it somewhat compact. We're going to negative diff this lesson. No, I'm just kidding. We'll talk about this in the lab. You bring your questions, and we'll have a little exercise this week. All right. So we'll talk to you later.